Hey girl, here's your chocolate for you.
Thank you, Uncle. Uncle, today I learned what is body mass index in school.
Wow, my niece so smart
Come, I help you calculate. What is your height and weight?
My height is 1.7 meters, my weight is 100 kg.
Oh my god, you're 34.6. That is in the obese category.
I must learn to enjoy life. YOLO! Ugh.
Oh no! Uncle! Uncle, you okay or not? Somebody help! Oh no, I must call 995. Hello? Hello? Yeah, we have an emergency. Unconscious. Doctor, how's my uncle?
Sorry to inform you, but he's high blood pressure and is currently in H2 category.
H2 category? I learned that in school. Does he have any association with his BMI? Because I calculated and he was obese.
I'm sorry, but I'm not sure about this, but you can find out more.
Okay.
Dr. Low, code red at Ward 75.
Sorry, I have to rush now. Sorry.
Well, I owe it to my uncle to find if there's an association between BMI of normal blood pressure and those with H2 BP. But first, I'll need the help of my professor. Professor! Yes? I found out what to do for my research question already. Oh, what happened? Okay, because my uncle is currently in the hospital and the doctor says that he has H2BP. And I calculated his BMI and he was in the obese category. Okay, well, what's your research question then?
Our research question for today is there a difference between the body mass index of people with normal blood pressure and those with high stage 2 blood pressure?
So here is our independent variable, IVE, which is our blood pressure. And there are two levels. We measure normal and H2, as well as dependent variable, which is our BMI.
So for blood pressure, it's actually the force of blood acting on the walls of blood vessels. The normal BP is 120/80 mmHg and H2 BP is more than 160/100 mmHg.
For body mass index, it is the measure of body fat based on height and weight. There are 4 categories. If you have a BMI of less than 18.5, you are underweight. If you have a BMI of 18.5 to 24.9, you are normal weight. If your BMI is 25 to 29.9, then you're overweight. But if you have a BMI of 30 or greater, you're obese. So sad for you.
For this experiment, I will need 200 volunteers, 100 for the H2 BP level and 100 for the normal BP level. And in each level, I need 50 males and 50 females so that it's a fair comparison and gender is not affected. Okay, well, I can help you collect the volunteers. Okay, thank you. Just call me, okay? Bye. Bye. Hello, Professor.
Sami, I found all of the 200 volunteers. So when would you like to meet them to measure their weight and blood pressure?
Oh, how about today?
I think that should be fine.
Oh, okay. Thank you. Good afternoon. Thanks for volunteering. So today, I'll just be taking your height and your weight. So sir, would you like to step forward?
Okay, I first omen.
Sorry, please go back in the queue.
Okay, omen first.
Okay, please place the umbrella there. Okay, so I'll take your height. 160. Okay, please step on the main scale. 48 kg. Okay, thank you, sir. You may step up. Okay, thanks for volunteering. Okay, next.
Finally me.
200 patients later.
Wow, that was tiring. But I finally got all the data I need. Yes! Descriptive statistics.
Woo!
So these are the summary statistics for the normal BP.
Don't forget H2BP. You see, the H2BP, the mean is 27.8 or the median is 27.1. See the difference? Only 0.7, so small.
But look at my values, they're all closer to each other. Hence I'm more symmetrical than you.
Whatever. See, the range is 25.7, or the interquartile range is 5.3, the variance is 20.8, the standard deviation is 4.6, and coefficient of variance is 0.164.
But look at my values, they are lower than yours. My range is 17.2, my interquartile range is 4.6, my variance is 12.5, my standard deviation is 3.5, and my coefficient of variation is 0.146, which is way lesser than yours.
So what? Really using standard deviation what?
But my standard deviation is still lower than yours, so I have a lower spread.
Whatever. You see, the skewness is only 0.840, and my kurtosis is only 1.360, which is between -2 and 2. That means my distribution is normal.
But my values are closer to 0. My skewness is 0.004 and my kurtosis is -0.210, and that's why I am more perfectly symmetrical than yours.
Anything.
So my 5-number summary is smallest data value is 14.1, the lower quota is 21.7, median is 24.4, upper quota is 26.3, and largest data value is 31.3, which is very lower than yours.
You see, mine is higher. My smallest data value is 19.0, lower quartile is 24.7, median is 27.1, upper quartile is 30, and my largest data value is 44.7. In your face.
Whatever. Look at my histogram. It's better than yours.
Please, but at least mine only have one pig.
But yours is pointing like a middle finger.
Quite funny.
So look at my box plot, it has lesser outliers than yours.
But at least my outliers are not lower outliers. And also, you see my box plot is so much higher than yours. That means it's so much better than yours.
Okay.
So concluding, the summary statistics showed that H2BP group generally have a higher BMI than normal. Also, the outliers are kept because they are medically important. You see, the outliers are important. The mean and SDs are used to compare between the groups. So sadly, my H2BP group is higher and therefore slightly more spread out than a normal BP group. The position of the box plots also showed that H2BP group consists of relatively higher BMI values compared to BP, the normal BP group. Therefore, we conclude that having a high BP leads to a higher BMI and vice versa.
Okay, fine. Inference data.
Yay!
So we conducted a hypothesis test on the variances. We used a two-tailed F-test, where the null hypothesis, the ratio is equals to 1, and the alternative hypothesis, the ratio is not equals to 1. The level of significance was 0.05, and the p-value that we got was 0.012, which is less than the level of significance. Hence, the null hypothesis was rejected.
No!
This means that the variances are unequal.
For the same test, using the critical region method, we found out that the two critical values are 0.673 and 1.49. So any values that are less than 0.673 or more than 1.49 will reject the null hypothesis. The test statistic that we found is 0.6, which is in the critical region. Therefore, using this method, the null hypothesis is also rejected.
Why?
Oh yeah, not forgetting, the 95% confidence interval for the variance ratio is 0.404 and 0.893.
Next, we conducted a hypothesis test on the means with unequal variances. We conducted the test using a two-independent sample, two-tailed t-test. The null hypothesis is when the differences are equal to 0, and the alternative hypothesis is when the differences are not equal to 0. We use a level of significance of 0.05, and the estimate for the difference is -3.637. The p-value that we got was almost close to 0, and hence it's less than the level of significance. Therefore, the null hypothesis was rejected.
For For the same test, using the critical region method, the two critical values that we found was plus minus 1.97. So any values less than minus 1.97 or more than 1.97 will reject the null hypothesis. So the test statistic that we found is minus 6.0. Sorry, my bad. Minus 6.3. Therefore, the null hypothesis is rejected.
Why does this keep happening?
And of course, the 95% confidence interval for our differences is minus 4.775 and minus 2.499. Yay, Clement's falling down.
Whatever. There are type 1 and type 2 errors. In type 1 error, there is no difference between the two BMIs of the two different levels of blood pressure, but the test statistics conclude that there is a difference. Therefore, H0 is rejected wrongly. In type 2 error, there's a difference between the two BMIs of the two different levels of blood pressure, but the test statistics conclude that there's no difference. Therefore, H0 is not rejected.
Ooh, check out those guns.
Okay, here is the power of the test conducted, and we actually collected, and the sample size for each group is 100, and the difference is negative 3.637, and from here we calculate our pool SD, which is 4.08, and in the end we actually obtain a power of 0.99999, which is 99.9%. And here is our final conclusion. We conclude that therefore individuals in the H2 category have a higher BMI than individuals in the normal category for blood pressure.
Professor, I got my results. Very interesting. I'll give you. Oh my god! I got an A plus! Now to share these results with my doctor and my uncle. Thank you, Professor. Bye. Bye. Oh, guess what? I found something very interesting. There's actually an association between BMI and BP. Look, this is my report. I got an A plus. Thank you.
Wow, my niece so smart.
Uncle, once you get out of the hospital, right, you must lose weight, because you must lower your BMI.
Bye.
Yay! Ooh, look, we are a normal distribution.